that being more flexible makes you better off in these models. So what this is going to mean is that in the short run, the outcomes and choices we have are fewer than the ones we have in the long run, because in the short run, capital is fixed, in the long run, it isn't. So we're going to have options in the long run that we don't have in the short run, which is going to, in certain scenarios, make us better off in the long run, which we will see explicitly. And we're going to see this yoga theorem again and again and again, where more flexibility is really a good thing. Okay, so let's put our mind to work for a minute. Actually, we have about 50 minutes left, which is great. And let's live in the short run for a moment, right? We're going to move on into the long run towards the end of class, but for now I want to think about short run production. So in the short run, let's remind ourselves that we're producing some output, soy lattes with extra foam, with one variable input, which is number of units of labor, and one fixed input, which is capital. So think of number of baristas and number of espresso machines as labor and capital, respectively. So this all seems terribly abstract. So now what I'm going to do is I'm going to show you for a firm the amount of output a firm can produce efficiently if nobody's sitting around slacking for different amounts of labor, holding the amount of capital fixed, right? So I'm going to fix the amount of capital available to the firm, and I'm going to ramp up labor, and I'm going to see what happens to the firm's level of output. Now tables are boring. Stare at this incredibly boring table for a second and ignore this and ignore this, because we're going to get to that in a second. So what do you see in the first column? It's capital. Does capital change? It's always fixed at 8 units. Why 8 max? Because I like the number 8 a lot. It's infinity at a 90-degree angle. It's a beautiful number, right? So we're going to keep capital fixed at an arbitrary number of 8 units, and I'm going to start ramping up labor from 0 units to 13 units, because I like prime numbers, all right? What's the next column here? The next column here is going to be the amount of output you can squeeze out of, let's look at the first row, 8 units of capital and no labor. So if you have an espresso machine and nobody to operate it, you're going to produce 0 espresso. Espressi. Oh, the plural. I don't even know. Somebody look that up and enlighten me. So as soon as I add the first unit of labor here, that firm can produce 5 units of espresso. And when I add 1 more unit of labor and I go to 2 units of labor, the firm produces 18 shots of espresso, 3 units of labor, 36, 4, 56, 5, 75, and you can read as well as I can that there are numbers that keep on going up, 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 plateau, fall, emergency, right? So the point here is I'm adding more and more labor, and it goes up and then plateaus and falls somewhere. So let's, instead of looking at this incredibly boring table, take this same table and let's plot it out. This is kind of fun. Reminds me of what my kid's doing in preschool right now. So you're plotting out combinations of numbers. So on the x-axis we have labor. On the y-axis we have output. So the third dimension we've ignored here. We're just holding capital constant at 8 units. So we're just plotting output against labor, but always remembering that capital is 8 units here. Use a red pen. Okay, so at 0 units of labor, we're producing 0 units of output. 1 unit of labor, 5. 2 units of labor, 18. 3 units of labor, 36. 4 units, 56. 5 units, 75. 6 units, 90. 7 units, 98. Bless you, 8 units, 104. Oh, sorry, this one's bad. So 7 units, 98. 8 units, 104. 9 units, 108. 10 units, 110. 110, 108. 9, 10, 11. So at 12, we're at 108. And at 13, we're at 104. Okay. That looks like a pretty cool curve, right? So I'm doing this as discrete units. I'm going to connect the dots like when you're going at Rubio's, right? They hand you that little thing and you can connect the dots while you're waiting for your tacos. Missed it at the end there a little bit, but no damage done here. Right? Capital is held constant at 8. And this here is going to be my total output curve. But in economics, we always use product and output interchangeably. So I will call this the total product, but you can call it the total output curve if you want it. It shows me, holding capital constant at 8 units, what happens to output as I add more labor. That's pretty neat. So we're going to explore the shape of this thing in more detail than you wish we did. But one thing you're already nervous about is this part right here. Why is this dropping, Max? Well, this thing is dropping. Let's think you have one espresso machine, small Starbucks, right? And you have 13 people running around behind the counter. What's going to happen? It's going to resemble the great movie Paddington the Bear, right? It's going to be a pretty messy affair in the sense that you have 13 people running around behind a small counter, everybody gets in each other's way, and in some sense the sort of initial increases in productivity from division of tasks, one person taking the cash, you would figure Starbucks had figured this out by now, but they haven't. One person takes the money, the other one does the baked goods, the third one does the sort of coffee and tea, and the fourth one makes espressi. So you get division of labor gains initially, but at some point you have so many people running around that people get in each other's way and total output actually starts falling. In the last lecture, which is the most fun lecture on the Cal campus, I will demonstrate to you that this is actually the case. All right, so that's the first one. That's the total product curve. Sir?
You didn't want to fill in those other 2 charts. That's related.
Which ones?
You crossed them out. Marginal product, labor, marginal product.
Oh, we're doing that right now.
Okay, just 2 slides back, so we're going to do it in 4.
Okay, so I'm giving you the all information for the firm, and what I'm about to do is so right now we did these 3. My next slide is going to look at this one, and the one thereafter is going to look at that one. Right, so I'm just squishing them together in a way that makes it clear. So we're going to do average product and marginal product. So the marginal product of labor, its related cousin is the marginal utility, right? Marginal utility was the amount of additional utility I get from 1 more unit consumed, right? So the change in utility from a change in consumption. Marginal product of labor is similar, only now we no longer have utility on the y-axis, we have output or product on the y-axis, and on the x-axis we have labor, right? So holding capital constant, what the marginal product of labor tells me is what's the change in output if I add 1 more worker, right? So the counterfactual you want to keep in your mind, or sort of the vision you want to have in your mind here is the manager at Starbucks stands there, looks at how many workers are currently working, and tries to figure out how many more espresso drinks could I serve if I put 1 more worker on the line right now, right? So what's the change in output from increasing labor by 1 more unit? Holding capital meaning the number of espresso machines fixed. So that's it in words. This is it in math. MP lowercase l, marginal product of labor, is the change in output due to a 1 unit change in labor. So if you want to ask a question, this is the question it answers. I'm obsessed with presenting things 3 ways, and on this slide it doesn't work so well. But basically what you want to know is if I hire an additional worker, how much does output increase or potentially decrease by? And what we're not asking here is should I actually hire that additional worker or not, right? I just want to know the answer to is it going to increase output, and if so, by how much? The should I is something we will look at when we actually talk about costs. Okay, so here's the rest of the table. So we're holding capital constant at 8 units. So now you've got column 2, 3, and 4, I believe, from that table right in front of you. It's the exact same numbers. So what we've got here is we've got the amount of labor, again, going from 0 to 13. Q here is the same output figures that we've just plotted in that weird-looking total product curve. And what I've done here on the right-hand side is I've given you the marginal product of labor, but then, oh my God, somebody left a couple of cells blank. Can we fill them in, right? Let's have a little bit of fun with filling in marginal product numbers. It's easy, and it'll keep us awake, okay? So what we're asking is the first one is always blank because you don't go from negative to 0 or something like that. So you always go from no labor to the first unit of labor. So if I go from 0 to 1 unit of labor, my output goes from 0 to 5, right? Output goes up by 5 units, so marginal product of labor is 5. Now I'm at 5 units of output. If I hire an additional worker, my output goes from 5 units to 18 units. So the marginal product was 5, is now 18, so the marginal product is 18 minus 5 is 13. For the third worker, I'm now producing 18 units of output with my two workers. If I hired a third one, my output would rise to 36 units. My marginal product would be 18 units. 36 minus 18. You can keep on going, and just in order to convince yourself that you've got this intuition down, let's figure out what the marginal product of the sixth worker would be. You had 75, you're going to 90, so it's 90 minus 75, so the marginal product here is going to be 15. Or down here, if you add the 11th worker, so you had 110 units with your 10 workers, you're going to the 11th worker, you still have 110. 110 minus 110 is exactly 0. So can we draw this marginal product of labor? Of course. The way we always draw it is the following. We draw it on the x-axis, you have units of labor. On the y-axis, you now have the marginal product of labor, or the average product of labor, which I'm going to show you in a second. And you're holding capital fixed in the background, right? So for 8 units of capital, what does the marginal product of labor look like? Again, you're just going to plot labor from 0 to 13 against MPL. So at 1 unit, it's 5. At 2 units, it's 13. At 3 units, it's 18. At 4 units, it's 20. At 5 units, 19. 6 units, 15. 7 units, 8. 8 units, 6. Oops, right here. 9 units, 4. 10 units, 2. 11 units, 0. Max, the universe ends right here at 0. It doesn't. We can deal with negative numbers. Max just didn't give you the axes, so let's draw them in. Minus 1, minus 2. We need more. Minus 3, minus 4. So at 12, it's minus 2. At 13, it's minus 4. All right, do this at your own risk. Connect the dots. That thing looks pretty cool. Okay, this here is your marginal product of labor curve. So what do we have? Right, for the first couple of units, adding an additional worker just really ramps up additional output quite a bit. Imagine a Starbucks on Oxford Street with one barista, right, handling the cash register, baked goods, coffee, making the coffee, and clearing the thing that never has sugar table on it, right? So what you get with the second unit of labor hired, all of a sudden that one person is going to be like, okay, I'm going to make the drinks, and you're going to deal with cash and baked goods. So what we're seeing here is division of labor. Then you get a third person added, baked goods, money, coffee. Fourth person hired, baked goods, coffee, money, pour the hot coffee that doesn't require an espresso machine, right? But then at some point, the next additional worker hired here actually doesn't have as high of an additional output impact on overall output as the last one hired. So the point here is that marginal product is still positive, right? So if you're hiring the 7th person, you're still adding 8 units of output by hiring that 7th person, but the jump in output isn't quite as high as that for the 2nd, 3rd, 4th, and 5th person, right? One question to check your intuition. Would you ever think that a rational profit maximizing firm with 8 units of capital would ever hire 11 or more workers? No, right? You wouldn't, because you have to pay them a wage and they actually diminish output. This is the equivalent of hiring your cousin who eats your ice cream, right? And doesn't do any work, and you have to pay him an hourly wage. So we will see soon enough, when we look at supply curves and so on, that firms will never hire down here. What we will also learn, which is going to be pretty exciting, is that firms generally won't hire in equilibrium to the left here. Firms are going to end up being somewhere on this part of the curve where we have diminishing marginal product of labor. Why that is right now should seem to you like a complete mystery, and that's my job to explain to you why that is the case. But what we've got here now is we've got our production displayed in a different way, right? We've got the marginal product of labor, which tells me the additional output from hiring one more worker, which is really ultimately going to drive how many units of output a firm is going to produce based on how much labor they hire. So this is one of the most important curves that you will see in production theory, so be sure you understand what's behind it and read a little extra in your excellent textbook on this one. So the last concept that's important in the short run is something called the average product of labor. So general rule of thumb in economics, the most important insights come from things that have the word marginal in front of them, which is completely counterintuitive. But marginal drives behavior in economics, average doesn't. Journalists live in a world where averages are important and marginal doesn't matter, which is why they in 90% of the cases in any op-ed always get the economics wrong, right? But that's another discussion to be had over a beer at some point. Alcohol-free, of course. So the average product of labor is different from the marginal product of labor. It doesn't tell me how much additional output the next worker hired would produce, but it just tells me the average output produced per worker, right? So we're no longer interested in how much does output rise by if I hire one more worker, but I'm just going to look at the total output of the firm, right, 100 units. If we're currently employing 10 workers, the average product of labor is 100 divided by 10. So it's averaging over the productivity of all workers, right, instead of just looking at that last person hired. So APL is really simple. It's just a ratio, total output divided by labor. So let's draw that same thing, and then I'm going to show you some really cool drawing, which I'm guaranteed to screw up somehow. So average product of labor. Oh, wow, Max left out some numbers again. That's exciting. Average product of labor simply means you divide quantity by labor. So if you're currently hiring one worker and you're producing 5 units of output, it's 5 divided by 1, right? On average, each worker produces 5 units. If your firm's producing 18 units, you're hiring 2 workers. Average product is 18 divided by 2. So 56 divided by 4. Anybody? 14, thank you. And then 108 divided by 9. Anybody want to dare? Oh, thank you. All right. So that's average product of labor. Can we draw it? Yes, we can. Let's do it. We can go through this pretty quickly because this really is more tedious, and then we'll spend a bunch of time on the intuition behind this stuff. So average product of labor at 1 unit is 5. At 2 units, it's 9. At 3 units, it's 12. At 4 units, it's 14. At 5 units, it's 15. That's 6 units. It's 15. That's 7 units. It's 14, 13, 12, 11, 10, 9, 8. So the average product of labor, if you connect the dots, looks something like that. And again, capital is held fixed at 8 units. Okay. So what I want to think about for a second, this is wrong. What I want to think about for a second is how are those two things related? So the best way I could possibly think about explaining the intuition behind this is to think about grades, right? If I get one more call by a concerned parent, why did my kid get a B- in your class? The answer will always be because he or she earned a B- in the class. But grades in classes are really important because everybody seems to think that an A- on your transcripts will ruin your career prospects. Okay, I've got a funny story about that. If we have some extra time in the end, I'll tell you how I got here. It's a good story. But the point is, an A- isn't going to ruin your career prospects, all right? It won't. But let's think about marginal product and average product in terms of grades. So the average product you can think of as your GPA, right? If right now you've got a solid 3.0, you're feeling a little bit depressed about it, and I would like to remind you that you are at one of the greatest schools in the entire world, as far as I'm concerned, the greatest school in the entire world, and you're getting a B average. You're doing pretty well, all right? So yes, there are people here who get 4.0s and get university medals, but in the grand scheme of things, you're doing very well, all right? But let's think about your average product as your GPA, and your marginal product as your grade in IAS 106. So if you get an A in IAS 106, what's going to happen to your GPA? It's going to go up. If you tank and you get a B, actually I don't give Ds because then you can't repeat it, but the point here is if you get a C-, what's happening to your GPA? It goes down, right? So the average product is your GPA. It's the average over all the courses you've taken so far, and the marginal product is that grade in the next class you've taken. If your marginal product is higher than your average product rises. If the next class you take has a higher grade than your GPA rises. If your marginal product is below your average product, then your average product falls. If you tank IAS 106, your GPA will likely fall. So what this means is we've got an average product of labor, which is rising, and then it's falling. So if the average product of labor is rising, that means the marginal product of labor must be above the average product of labor. If the average product of labor is falling, that means the marginal product of labor must be below the average product of labor. So I'm going to draw something and then I'm going to erase it, okay? But just to show you what this should look like. It should look like something like this, right? And we'll do the exact same thing in a second, right? So your marginal product of labor should be above the average product where average product is rising, and it should be below the average product where average product is falling. Well, if it's above average product where average product is rising, and below average product where average product is falling, what that means is marginal product must cut through average product right at the peak of average product where average product goes from rising to falling, right? So let's check that that's true. Okay, this will just take 5 seconds, and I think it's worthwhile doing because you're going to draw this picture a million times. So if you go back to your marginal product curve here, let's do marginal product in green here. You've already drawn it, and I'm going to do this rather fast here. 1, 5, 2, 13, 3, 18, 4, 20, 5, 19, 6, 7, 8, 7, 8, 8, 6, 9, 4, 10, 2, 11, 0, 12, minus 1, minus 4. And the one I've left out here is, that should be a 15, right? So these are the marginal product dots from the table I gave you initially. If I connect these, it looks something like this. Right? All I needed was my labor and output. And from labor and output, I can get the marginal and the average product. But what I'm learning from my marginal and average product here is average product looks a little bit like a turtle shell, right? And the marginal product is above and rising where average product is increasing, and decreasing and below average product where average product of labor is decreasing. So that's the first piece of insight. I'm going to give you a little glimpse into the future for a second. You don't have to fully internalize what I'm about to tell you, but just so you know, I'm not just telling you this stuff because economists think it's important and it doesn't really matter in the grand scheme of things. How much you produce for every amount of labor holding capital constant here tells you how much it's going to cost you if you know the price of labor and the price of capital, wages and price of capital, per unit of output produced. So the firms are ultimately going to decide how much to produce in terms of how much money do I get for my output relative to how much it's going to cost me to produce. So we're going to translate these average and marginal product curves here into something called the marginal cost and average variable cost curves. The marginal cost curve is going to tell the firm how much output it should produce. The average cost curve, average variable cost curve, is going to tell the firm when it should shut down and cease production. So while this might seem somewhat boring, it doesn't just seem boring. I admit this is incredibly boring. It is really important, all right? This is sort of like when you want to study to be an artist in the first class, you get a big anatomy book put on your desk. You're like, I want to be an artist. I don't want to learn anatomy, right? You've got to learn anatomy in order to be able to draw the human figure. That's just the way it goes. So similar thing here. You've got to understand